Look at the money in your wallet. What gives it its value? Is it backed by gold, by silver? The truth is, it's backed by absolutely nothing. But to understand how we got here, and how a mysterious document from 2008 changed everything, we need to go back in time. Thousands of years ago, if you wanted something, you had to trade for it. You had chickens. Your neighbor had apples. You made a deal. This was the barter system. But it was complicated. What if your neighbor didn't want chickens today? Humanity needed a better system. We moved to commodities, and eventually, the ultimate winner emerged: gold. Why gold? It's durable, it holds its value, and most importantly, it's limited. You can't just magically create more gold. Throughout history, kings and empires stored their wealth in it. But gold had one massive flaw: it's heavy. Try carrying a bag of gold coins across the country to buy a house. It's a logistical nightmare, so the banks came up with a brilliant solution. They said, "Give us your heavy gold, we will lock it in our safe vaults, and in return, we'll give you a piece of paper." This paper money was essentially a receipt. At any given time, you could walk into a bank, hand them the paper, and get your gold back. Money had real, tangible value. But everything changed on August 15, 1971. U.S. President Richard Nixon shocked the world. He completely disconnected the U.S. dollar from gold. From that day on, money became what we call fiat money. Its value is based solely on trust in the government. And the biggest problem? Governments can now print an infinite amount of money whenever they want. And when you print endless amounts of money, the money you already hold loses its value. This is the root of inflation and many of our modern economic crashes. Fast forward to the internet age. Visionaries realized our financial system was broken and tried to create digital money. But they all failed because of one massive technical hurdle: the double spending problem. Think about it. If I take a digital photo, I can copy and paste it, sending it to 10 friends at once. In a digital world, what stops someone from copying a digital coin and spending it twice? Without a central bank to verify the transactions, digital money seemed impossible. Then came 2008. The world was facing the biggest financial crisis in modern history. Banks were collapsing. Trust was at an all-time low. And right at that moment, an anonymous person, or group, using the name Satoshi Nakamoto, appeared out of nowhere. Satoshi published a 9-page document known as the white paper titled Bitcoin, a peer-to-peer electronic cash system. Satoshi had done the impossible. They solved the double spending problem without needing a bank. Now, if you read this white paper, you might think you need a PhD in mathematics and cryptography to understand it. But don't worry, you don't need a PhD because I am here to explain it to you. Satoshi Nakamoto didn't just invent a new digital coin. To make Bitcoin work without a bank, they had to invent a completely new, revolutionary underlying technology. This technology is called the blockchain. Simply put, a blockchain is exactly what it sounds like: a chain of blocks. Imagine a traditional bank's ledger, a book where they write down every transfer. In the digital world, a single block is just one page in that ledger. Inside this block, we have data, specifically transactions. For example, Alex sent Sarah $500 on Tuesday at 10 a.m. When this block gets full of transactions, it closes. But how do we secure it? How do we make sure no one alters that page? This is where the magic of cryptography comes in, using something called the SHA 256 encryption. Think of SHA 256 as a mathematical meat grinder. You can put any amount of data into it, a single word or an entire book, and it will always spit out a unique, fixed-size code made of 64 characters. This code is called a hash, and it acts like a digital fingerprint for the data. If you change even one single letter in the original data, the entire hash completely changes. So let's look inside a completed block to see how this actually works. Imagine a block filled with transactions. First, every single transaction gets its own unique SHA 256 hash. Then, the system takes all of these individual transaction hashes and bundles them together to create one main master hash for the entire block. But here's the genius part. To create this master hash, the system doesn't just use the transactions. It also includes the master hash of the previous block. This is the mathematical glue that permanently chains the blocks together. Because every block's master hash is mathematically locked to the one before it, the system becomes practically unhackable. Let me show you why. Let's say a hacker tries to break into block number 2. They find a transaction that says, Alex sent Sarah $8,000, and they try to secretly change it to just $800. The moment they change that number, the unique hash for that specific transaction instantly changes. Because that one transaction's hash changed, the master hash for the entire block 2 is forced to recalculate and changes completely. But remember, block number 3 was built using the old master hash of block 2. So now, block 3 detects a mismatch. It realizes the previous hash it holds no longer matches block 2, and block 3 immediately becomes invalid, which makes block 4 invalid, and block 5. The entire chain breaks in a massive domino effect. But wait, if a hacker has a supercomputer, couldn't they just recalculate all the hashes for the rest of the chain in a matter of seconds? This is exactly why Satoshi added one more genius rule to the system: proof of work. Satoshi made it intentionally difficult to create a new block. The network dictates that a block's master hash must begin with a certain number of zeros. For example, it must look like this: 0, 0, 0, 0, followed by the rest of the code. But we already know that if the transactions are locked in, the hash is always the same. So how can we change the hash to magically get those zeros at the start? Inside every block, there is a special empty field called a nonce, a number used only once. The computers on the network must guess this number. They try the number 1. They generate the hash, no zeros. They try the number 2, no zeros. They try millions of numbers every single second. This massive guessing game takes an immense amount of computing power and electricity. That brutal effort is the work. Once a computer finally guesses the exact number that produces the right amount of zeros, they have the proof. Only then is the block permanently added to the chain. Now, let's go back to our hacker. To successfully change that $8,000 transaction, they don't just have to instantly recalculate the hashes. They have to redo all the proof of work for block 2, block 3, block 4, and every single block after it. They would need to outcompute the entire world, which is physically impossible. Even if they somehow managed it, the rest of the computers on the network would look at the hacker's altered chain, compare it to their own authentic copies, see it's a fake, and instantly reject it. This is why Satoshi's creation was a masterpiece. It replaced trust in governments and banks with mathematical certainty. We finally have a financial system run by completely untrusting strangers, yet it remains the most secure network in human history. Bitcoin didn't just solve digital money, it returned the power of true ownership back to the individual.